All right, these are going to be notes 21. We are going to be interpreting the average rate of change in context. We are going to be using the average rate of change formula, which I introduced to you students on during notes number 20. We still will be using the same formula for average rate of change, which is um, f of b minus f of a over b minus a. Um, FYI, I did not leave copies of the handout for the notes, but I will provide you with a copy of a completed set of notes on Thursday when I return. All right, so again, we'll be using the same formula for average rate of change. We have f of b minus f of a over b minus a. And today we're going to be interpreting the word problem or the data that we're collecting. Okay, so let's look at the first example. We have find the average rate of change number of households with landlines from 2008 to 2011. So again, 2008, 2011. So now if I look at my number of landlines per million from 66 to 51, that is a drop of 15. And then from 2008 to 2011, that is an increase by 3. So my average rate of change is negative 15 over 3, which is equal to negative 5. So now we're going to write a statement that tells us what that number represents. So I would write so it says the average rate of change is decreasing, and kind of your hint why I'm using decreasing would be the negative. That's where the decreasing comes in by 5 million landlines. And we were thinking like, where'd you get landlines? Right here. Those are the landlines per household. And it says every year. That's my X value every year. And I also have to state the interval, because if I don't state the interval, someone can make the assumption that from 2009 to 2011, my average rate of change is decreasing by 5 million every year, which could be the case, but it could also be something different. Okay, so let's go to the next example. We have example 2. It says the amount of bacteria on any given day is shown on the table below. Find the rate of change in the amount of bacteria from day 2 to day 5. So we have day 2 and then we have day 5. So from 30 to 121, that is a change of 91. And then from 2 to 5, that is a change of 3. So my average rate of change is 91 over 3, which if I simplify that, I should get about 30.3. So now I'm going to write my statement. So it says bacteria is increasing by 30.3 every day from day 2 to day 5. Okay, so again, a few hints. Where did I get bacteria from? Here. Why am I using the word increasing, sorry, this time instead of decreasing? Because my final number that I have is positive, and I am using the interval of 2 and 5 because that's what's being asked originally. Okay, so let's go to the next problem. It says suppose an object is thrown upward with an initial velocity of 48 feet per second from a height of 120 feet. The height of the object t seconds after it is thrown is given by the equation h of t equals negative 16t squared plus 48t plus 120. Find and interpret the average velocity from t is equal to 2 to t is equal to 4. So the first thing I'm going to do is I am going to substitute my t value of 2 into the function, and I have h of 2 is equal to negative 16 times 2 squared plus 48 times 2 plus 120. That gives me h of 2 is equal to negative 16 times 4 plus 48 times 2 plus 120. That gives me h of 2 is equal to negative 64 plus 96 plus 120. That is going to give me h of 2 is equal to, okay, when I combine these two, I should end up with 32 plus 120. So I have h of 2 is equal 152. So my first point that I'll be using is 2 comma 152. And now I'm going to repeat the same process, but now with t is equal to 4. So I have h of 4 is equal to negative 16 times 4 squared plus 48 times 4 plus 120. So I have h of 4 is equal to negative 16 times 16 plus 48 times 4 plus 120. Okay, so now I have h of 4 is equal to negative 256 plus 192 plus 120. So I have h of 4 is equal to negative 256 plus 192 plus 120, which gives me 56. So my second point I have is 4 comma 56. So now I can go ahead and go back to the formula, which is f of b minus f of a over b minus a. Again, this is your a, this is your f of a, b, and f of b. So I have 56 subtract 152 all over 4 subtract 2, which gives me negative 96 over 2. And if simplify, I get negative 48. So for this one, that means that, and I'll try and fit in my work here, the So the height of the object is decreasing by 48 feet every second from 2 to 4 seconds. All right, last example. It says suppose a large grapefruit is thrown up straight upward in the air at t equals 0 seconds. The grapefruit leaves the thrower's hand at a high speed, slows down until it reaches its maximum height, then speeds up in the downward direction and finally splat. Find the average velocity of the grapefruit during the first 4 seconds. So this one, look at the intervals. Some of you are gonna think 1, 2, 3, that's 4 seconds. But if you look, pay attention, this is 1 second, this is 2 seconds, 3 seconds, and 4 seconds. So you're actually going to be using from 0.4 to 432. So from 0.4, my change is a +4, and from 4 to 32, it's a +28. So you have 28 over 4, which gives you 7. So that means the height of the grapefruit is increasing by 7 feet every second during the first 4 seconds. Okay. Lastly, you do have a handout. This one you do have a copy of in the classroom. So just make sure you get a copy, and you are more than welcome to work in groups.